Well, good afternoon, everyone, and welcome to the Tuesday, November 18, 2025 session in our series on innovations in AI from Asia. And I'm delighted to be able to welcome Dr. Tatsunori Hashimoto, who is professor of computer science at Stanford. Before I introduce our speaker and get the program introduced, I want to say thank you to the member companies of the U.S. Asia Technology Management Center. We are completely dependent on the annual fees and other support from our member companies. So they are the people who are making this program possible. We want to thank them and also thank each of you for your interest and support. It's nice to be here with the speaker actually in person. This has turned out to be remarkably rare this quarter. And in fact, in that regard, I have to announce that the final session in our series, which is Tuesday, December 2nd, will be Zoom only. Dr. Kai-Fu Lee, who is the founding director of Microsoft Research China, the former chairman of Google China, author of AI Superpowers and AI 2041, and currently the entrepreneur, founder, and CEO of 01.ai in China, is going to be joining us from Beijing. So we took a poll of students in the class and we asked, would you still want to come here and have our wonderful refreshments afterward? Or would you rather do it by Zoom and keep everything more kind of convenient? Well, convenience won 60% to 40%. So we're following the votes of those who let us know their preference, and we'll do Zoom only in 2 weeks. So today is our final in-person session for the series this fall. We do have refreshments outside afterward. We hope you'll stay and join and talk with each other and talk with our speaker as after our session. So Dr. Hashimoto, as assistant professor of computer science at Stanford, is studying robust and trustworthy machine learning systems. He's applying statistical tools to improve the reliability and fairness of complex models like LLMs or other foundation models, which is the current term. And before joining the faculty at Stanford, he was a postdoc here, but he got his PhD at that school in Cambridge, Massachusetts, right? MIT. And I'm reminded that in the 1960s and 70s, more founders of Silicon Valley companies graduated from MIT than graduated from Stanford. As a Stanford graduate, that's hard to say, but we'll move on from here. So I think you've got some prepared remarks. Let's ask for those, and then we'll have Q&A and discussion.
Great, wonderful. Thank you for the introduction. And I think part of the value that I bring to this session and also to all of you is that I'm also one of the main instructors for large language models in the computer science department. So I teach the big NLP class with Di Yang, and I teach sort of the more advanced language modeling from scratch class with Percy Liang. And so we think quite a bit about what are the underlying technological components of large language models. And now today I want to talk a little bit about how these underlying technological pieces relate to LLM development in Asia, or East Asia to be more specific. And before I get started, though, I want to talk a little bit about why there's a need for these kinds of regional language models or regional AI systems in the first place. And I think multilinguality has been a thing that's been studied for a long time in natural language processing. And people know that when you train language models or train natural language processing systems for certain languages, usually English, that's the kind of most common and dominant language for a lot of these systems, they don't perform as well in other languages. So this was part of the GPT-4 release technical report. It's very good in English on a variety of benchmarks. And as you sort of go down towards rarer and rarer languages, the system does worse and worse. And so, for example, if you're a Thai speaker, your experience is going to be measurably worse. You're at 72% performance compared to 85% for GPT-4. And this is not, sort of a negative result that I'm sort of cherry picking, right? This is OpenAI's own report, right? So this is a positive case result. Similarly, in the early days when Google released Palm 2, they had a similar table in which they're showing, well, on English, we got certain performance 23. I'm going to pick Pi again just as an example. We got a significant degradation in performance when we switch to Thai or Telugu or any of these lower resource languages. And so this has always been the case, right? So for as long as we have had machine learning systems, we've had this performance gap between sort of, popular languages and rare languages. And this is just really hard to get rid of because the easiest data to access and the most abundant data to access is English, right? Most of the internet is in English, or publicly accessible parts of the internet is in English. If you look at the speakers of different languages, right, that's a very different distribution. That's on the left compared to the distribution of text that is on the internet. And so, if you're, let's say, the Chinese government, right, you have all of these Chinese speakers, you might say, why are we using systems that are primarily designed and tuned for the English languages? And really, I think the issue has been that it's very, very difficult to produce multilingual corpora. And so, if we try to find, different kinds of multilingual data sets and we ask, oh, what fraction of the data set is what quality? It turns out that a lot of languages have very low quality data. And so it's very difficult to get models to perform well across a wide range of distributions. And the thing that's become even more sort of pressing in recent years is, in the old days, when NLP systems were about like syntactic parsing or sentiment classification, the stakes in some sense were much lower. Now, when we have systems that are sort of our everyday assistants, the stakes are much higher, right? You might go and ask ChatGPT, where should I go get breakfast, right? And if ChatGPT is like, oh, yes, you should go get the bagel because the bagel is the best food item, right? There's like a sort of cultural norm that's being slowly propagated through the language model. And people, including researchers here, have studied these kinds of biases, and they sort of, found, maybe unsurprisingly, that models produced in the West have very Western-centric biases. And the companies acknowledge this and know this. And so, companies like OpenAI are constantly trying to sort of shift the balance towards, being more global, reach a larger audience. But really, all of this kind of motivates the desire of every country, every language to potentially build its own language model, to build its own AI system, right? So this is kind of the background motivation for why there is so much effort across the world in each country trying to have its own homegrown, you might call it sovereign AI effort. And so now I want to kind of go through different countries in East Asia and talk about the various homegrown language model training efforts and sort of the different strategies, let's say, that they've taken in trying to think about language model deployments in different countries. And I'll talk about 3 different groups of countries or regions. China, I'm going to talk about quite extensively, and then Korea and Japan have taken somewhat similar strategies to some extent, so I'll talk about them together. And I'll talk about Southeast Asia as a unique and important sort of set of attempts at language model construction. So I think when we talk about East Asian AI developments, I think we have to really talk about Chinese language models, right? This is a big elephant in the room. And really, I think that the thing is now in 2025, at the end of 2025, it is pretty clear that especially if we're talking about open models, Chinese companies are at the forefront, right? And I think depending on how you're measuring the performance of these systems, they're getting quite close, if not parity, with some of the closed source labs. So I've taken this screenshot from Kimi K2. I think that's the most recent kind of frontier-ish release from a Chinese company. If you look at benchmarks ranging from like agentic reasoning or search or coding, you see that Kimi, this is a Chinese model, Chinese startup, is basically going toe-to-toe with a bunch of OpenAI and Anthropic models. And I'll caveat this point by saying, there has been accusations or arguments about, are these like startups really juicing the numbers on their benchmarks by really aggressively trying to optimize for those numbers? The answer is partially somewhat yes. Like you do see benchmark optimization behavior from a lot of these companies, but these models are quite good, right? These can't be really explained by purely benchmark overfitting. And there is a very large and strong ecosystem of language model training companies in China at this point. I've listed a bunch of companies and I've picked some out of sort of, because I wanted to talk about some of them in particular, but all of these companies have shipped some sort of like near frontier model. And that's kind of remarkable because if you compare this with, let's say, the situation in Europe, right? In Europe, you have, French Mistral. That's probably the one company producing frontier models, and that's kind of it almost. You might put Aleph Alpha in there. I don't know if you would. Whereas if you go look at China, you've got all of these companies like consistently producing frontier level models. And of course, you all probably know DeepSeek and Alibaba Quen maybe, but I think one of the ones I want to highlight because I just think it's so strange and amusing is Meituan, which is like their equivalent of DoorDash, has shipped a frontier model. And so really, in some ways, their DoorDash is producing models arguably equivalent to Meta here, which is kind of a crazy thing to think about. And I think part of the thing that's underappreciated, especially if you all have started thinking about or tracking this whole AI thing in the last couple of years, is like maybe you think about this as like a very like sudden phenomenon. It's like, oh, whoa, these Chinese companies, where did they come from? But I think as an NLP researcher, one of the things that I think about quite a bit is that there is a strong foundation in basic science research and scaling research and foundation models research pre-ChatGPT that was very sort of vibrant in China, right? Richard just mentioned Kai-Fu and like all of the sort of effort in like Microsoft research and Google research in China. There were companies like Baidu making Ernie 1.0. This was the Chinese alternative to BERT. It was one of the earliest replications of those kinds of results. We've got GLM, which is an open source GPT-3 model that came out soon after GPT-3. In some ways, Chinese NLP was competitive with a lot of what the West was doing, throughout the 2015 onward. There was a lot of investment in basic research. And I think this is part of the reason why, we see so many companies, we see so much success, because there's a very like deep talent pool there that has been built up by a lot of these efforts. And I think if you read a lot of the papers, you'll find that actually a lot of the things they talk about and think about are the exact same kinds of technical concerns that what you would call like frontier companies in the Bay Area think about, right? They're really pushing the frontier on really low precision training. So this one, which one was this from? This might have been IMI K2, is really pushing things like int4 quantization. That's like 4 bits for your weights, right? That's kind of crazy low. This plot on the top right's from DeepSeek V2. And, before DeepSeek V3 and R1 and all this social phenomenon took off, if you read their papers, you would know that they were doing the kinds of like careful scaling law research that characterized, top labs in the United States. And of course, this plot's from DeepSeek R1. They've done some wonderful work on post-training and reasoning. And at this point, I think I have to talk about DeepSeek R1 because everyone wants to hear about DeepSeek R1. And, if you look at the Google Trends chart, it's like no one's talking about DeepSeek, and then suddenly everyone's talking about DeepSeek. And really, there was, as I said, a base of real technical strength before DeepSeek R1, but there was kind of a remarkable point there where, we suddenly had a model that exceeded OpenAI O1. Not only that, they like publicized the recipe for how to replicate that, which really democratized the technology. And they had really just very good science about what was actually going on inside the models. I'm going to skip at least the technical details. But one of the things I'm struck with reading the DeepSeek paper as sort of an academic is that, these people are really doing careful science and also, doing the technical stuff right. Something that's missing even in, American academia these days. You read their section on like the things they tried other than DeepSeek R1, and they basically tried all the things that, American academics were trying to do to replicate, OpenAI O1, like Monte Carlo tree search or process reward models. The technical details may be, gibberish to you, but really the point here is that there were many different angles of attack to replicate something like OpenAI's thinking models. We could maybe have, Monte Carlo tree search or PRMs. All of these were different angles. And DeepSeek tried all of them pretty carefully, and then they figured out what the right one was in the end, which is outcome reward models. Okay, so that's kind of the environment of the companies. Now I want to talk a little bit about the geopolitical and other environments that's shaping the dynamics of Chinese LLM development. And I think one of the important things here is export restrictions and kind of the looming chip war that's happening between the US and China. So in the United States, if you want to go and build a startup that trains a language model, what you do is you buy a ton or rent a ton of GPUs from NVIDIA, and you do the usual things that are on the internet, and you train a big model, right? It's actually fairly straightforward. If you want to do the same thing in China, you actually can't easily do this. You basically have to get their sort of handicapped version of the GPUs because that's what's been allowed to be exported for the last few years. So the chart on the left is basically showing two measures of performance, memory bandwidth and like processing. So this is like how fast you can sort of multiply some matrices. So in America, we can buy like A100s, H100s, B300s, right? These 3 points are things you can buy in the US. If you're in China, you can only really buy the H20s, which are basically a version of the H100 that's significantly handicapped in terms of the processing performance. So similarly, instead of the B300, you can only buy the B30A. And this has led to the Chinese government encouraging essentially adoption and production of their homegrown alternative. So this one's the Huawei Ascend 910. It's actually a not bad chip. It's getting close to H100s in total performance, although it's much more power hungry. The bigger problem is that the total amount of fabrication capacity to produce these chips is very limited relative to the amount of sort of fabrication capacity that US and its partners have to produce NVIDIA chips. And so this really puts you in kind of a tough spot. You can buy handicapped NVIDIA chips, or you can buy a very small number of the producible Huawei chips. And this leads to actually really interesting and impressive systems innovation. So the DeepSeek V3 technical report, if you're technical and you're interested in this stuff, you should go read this paper because it really, highlights what, these companies do in order to basically build models despite these chip restrictions. And so, one of the things, this gets into slight technical details here, is, what's the difference between a version of a GPU we can buy in the United States, the H100, and the export controlled version, the H8100? Well, the difference is these things can, generally do things similarly quickly, but they can't talk to each other as fast. So once you need to go beyond one GPU, you suddenly get this bottleneck. They can't talk to each other quite as quickly. And so what do you do? What you do is you basically try to make sure that you don't communicate quite as much. So I'll skip these two slides. DeepSeek has this kind of crazy thing that they do where they basically, cut up the amount of communication that needs to happen between the different GPUs into different tiny slices. And then they sort of weave them together in ways that, you're communicating one chunk, and then while you're doing that, you're doing some processing on another chunk. And so you're basically always using the limited amount of bandwidth you have in very clever ways. This is a trick called dual pipe that they kind of developed. And it basically trades off one resource that you do have, which is memory on your GPU, for a resource you don't have, which is the ability to talk quickly across GPUs. So the technical details here aren't quite as important. Like you don't need to really understand what that diagram up there is. But the thing that's really important to understand here is that this kind of systems engineering, even though it's very difficult and it requires very skilled engineers, is not something that's like totally impossible to do, right? You can kind of figure this stuff out once you know the constraints and you know how to optimize. This has also led to some pretty interesting dynamics where I think a lot of the Chinese companies are really, really good at quantization. And quantization means you normally have a model that's trained with like a bunch of numbers, right? But maybe you can represent those numbers using fewer bits. So instead of using 32 bits to represent a number, you might use 4. And that has huge advantages because you can communicate those 4 bits much faster than you can communicate 32. And so a lot of the Chinese companies have invested very heavily into this sort of quantization technology, and that has led to also other sort of benefits. Like they can serve their models for much cheaper, which is also why you see, basically models like DeepSeek and Kimi K2 being served for really, really cheap relative to their US alternatives. The American companies, the Frontier Labs, are also quite good at this quantization stuff. But I think one of the reasons why the Chinese companies are also so good is because of the export restrictions. Okay, so that was the Chinese bit. And I think there's a lot of really interesting dynamics to unpack, and I'm happy to discuss some of this. And now I want to talk about sort of some of the other East Asian countries. There's not quite as much to talk about, but I think there's some interesting things that I want to highlight. So Japan, I think, is a pretty interesting case. There's been a couple of large-scale models that have been trained. And one of the ones I think really speaks to a really interesting dynamic about technological development in East Asia. So Japan has a couple different homegrown models. There's a consortium called LLMJP, which, as far as I understand, is maybe the most up-to-date or like the largest of these efforts. They've trained fairly large models. They have fairly good data sets. A lot of the other developments on the very right are driven by companies like NTT. I think Cyber Agent or someone also might have one. There's basically all of these like sort of private companies have also gone and developed a bunch of foundation models. But I think maybe the most interesting piece in the middle is kind of this Fugaku LLM. And I think I mentioned this not because this is like, a way to get frontier models, but also because I think, this is just kind of an interesting historical note, right? Japan has always been really on the top leaderboards of these like supercomputer leaderboards. They've built these giant high performance supercomputers, including Fugaku, which is, one of the fastest supercomputers in the world. And so, you would think that Japan is like very well positioned to take advantage of this compute heavy era. But the problem is that all of these are CPUs, right? Like they're designed for like, weather simulation, scientific computing, like a very different set of workloads than training large language models. And so despite the fact that you have these like gigantic, clusters that are very, very fast, because you have CPUs and not GPUs, you basically end up paying a huge overhead in training large language models. And so Fugaku LLM is trained on this really powerful cluster, but it turns out to basically be a middle of the road model in the end. I mean, it's quite an impressive effort that they managed to train this on CPUs at all, but you do have to pay a gigantic efficiency cost. Korea, I think, has a similarly healthy ecosystem. Naver Labs, LG have produced highly competitive internationally reasonably competitive models that can go toe to toe with open models in the West. I also think it's pretty interesting looking at kind of the Korean ecosystem that they seem to also have model training startups in the same way that in the US or in Europe, a lot of these model training startups have come and their training models. That's a dynamic that doesn't quite exist in the Japanese ecosystem. A lot of the Japanese foundation model training efforts are done in big traditional companies rather than in startups. And then finally, I want to talk about an important distinction and an important thing, I think, that sort of separates a lot of the efforts. So pre-training is the process of basically taking a really large collection of text and training a large language model from nothing, right? So this is the very basic process of going from nothing, like a random jumble of weights, to a trained, autocomplete system, a model that can predict the next word. This is incredibly expensive, right? This is kind of usually what people talk about when they say, oh, you need a big data center to train a large language model. This is the kind of thing that Qwen or a lot of these other Chinese companies are doing. Now, many efforts in sort of sovereign AI and multilingual model building are what you might call this continued pre-training thing. So that's this bottom one. Qwen, you would take a base model, let's say Qwen 3, you would take a corpus in your own language or in your own domain, and then you would basically adapt the model for that data set. And so now you can basically take a model that someone else trained, and you can make a Thai or Japanese or whatever else model. And this forms the bulk, I think, of the efforts in the multilingual model construction regime. I think, the trend is that it's really hard to compete with people like Qwen, who are doing just a phenomenal job releasing these open base models. You're much better off building on them than reinventing things from scratch. And so if you look at the Southeast Asian efforts, they have actually quite nice models adapted to the many diverse Southeast Asian languages. They're orthographically and linguistically very different than many of the other languages, but they're able to get good models for this using continued pre-training based on Qwen or Gemma or Llama and Qwen, right? So you can take all of these open source models, you can adapt them to a target language, and you can get much better performance for low resource languages. And I think this is a really important kind of effort. And I think the reason why maybe all these sovereign AI efforts are interesting, and also continued pre-training versus pre-training from scratch is interesting, is because of the kind of really rich geopolitical concerns that arise, right? So let's say everyone is taking Alibaba Qwen models and building their own nation's AI systems on the basis of that. Well, would that be a problem? Maybe, maybe not. And I think these are pretty interesting questions. As I said before, there's concerns that cultural and other values are sort of set by the people building these models. I think maybe more concerningly, there's lots of discussions about military and other applications of large language models. We recently saw from Anthropic a report that basically said they found some group in China that were basically doing cyber espionage using Anthropic models, and then they detected and shut them off, right? And so if you're basically doing state espionage in China, you would want to build your own language model because you don't want to be reliant on the US for that capability. And so I think there's a significant effort by many sort of government organizations to have their own AI systems they control for this reason. So there's very significant soft and hard power impacts. Okay, so just to sort of put things all together and to give you some things that maybe you can remember and take away, right? So modern LLMs are just very complex engineering challenges. And the countries that are doing well at this have just like a long base of sort of talent pool and basic research investment that are just now really paying off. There's a lot of reasons and lots of motivations to build country-specific models because general purpose systems don't necessarily fit all use cases. Although I'll be clear and say they're getting better all the time, right? Like the best, Google model today is probably better than any of the Southeast Asian models that I sort of pointed out at the very end, for example, right? It's just so much better at everything that even though it's worse at, let's say, Thai, it's still probably better than what you can make. I think geopolitical and sort of chip use restrictions are really interesting things that have shaped sort of Chinese frontier LLMs. And in the other Asian countries, we see lots of different strategies about base model training, CPT, that are sort of taking hold that people are adopting. So I'm happy to open it up for
That's fantastic. Thank you very much, Tatsu. I'm going to claim executive privilege and ask the first couple of questions. So when we first opened up this series, we noted that a lot of the Chinese models are, quote, open source. And most of the big industry models here are not. What's your take on that? Is that their response to this kind of restriction, or is it, how do you see open versus closed source?
Yeah, I think it's a couple of different things. I mean, I think everyone has their own theory about why they're open source. My personal one is that I think a lot of the Chinese companies, at least traditionally, have not been quite seen as legitimate as the Western ones. Like this is a kind of tradition that has gone back in like NLP and other kinds of research for maybe a decade,
regardless of whether that's warranted or not.
Exactly, right. And I think many of the systems that they built back in like the Berg days were quite good, right? It's just that they were viewed as, sort of trailing, following, and not quite as technically good. Even now, there's a lot of accusations about, oh, did DeepSeek just like copy off OpenAI, right? And so I think the openness is one way for them to very clearly get legitimacy for the things they're doing. I think that's one component.
Mm-hmm.
I think the other thing is it's a lot easier to be open when you're not number one. And so I think this is a very real sense in which I think, OpenAI, if they were number 10 or something, I bet they would be much more leaning towards being open source than, in their current state of being, having the best models. Because when you're number 10, the legitimacy or like publicity value you get from the open source release is higher than potential revenue that you get serving it through API. And so I think the economics for a lot of the Chinese companies are very different than in the US.
Okay. So another point is how much data there is in China for training model.
Mm-hmm.
I wonder if you would comment on the quality of the data and whether it's just a lot of very homogeneous data, or, how do you see that difference?
Yeah, I think that remains still a big unknown. So, the usual thing that people say, the common wisdom, let's call it, in language model training is like the most valuable stuff that you can train on are things like books, like encyclopedias, like also things like question answering websites, like Stack Exchange. All of that, I think, whether you're in China or not, doesn't really change. And I would argue probably the highest quality stuff, at least there, is still English. Now, I think there's an emerging question of whether things like social media data is really valuable. And I think, it remains to be seen how much information and value can be extracted from that. I think if it turns out that that's...
And that's not specific to China, that's just in general.
That's right.
Okay.
Right. And so I think, if we think about data in China, like I don't think there's, a big advantage in like encyclopedic knowledge, for example, right, on the internet or digitized. But I do think a lot of the companies there have really big, let's say, internal social networks or app networks. Like, you've got like all-in-one apps that like control a lot of the data. If it turns out that the kinds of like very noisy social media style data is very useful, then I think the companies there have a lot of advantage. There's like almost whole shadow internet that happens there, whereas I feel like in the US, the internet is much more open generally.
Okay. So we've got a question on Zoom that I'll get to first. Thanks for the wonderful talk. How do you see the future markets of LLM? Each country having its own dominant country-specific LLM, or still will the US big players dominate most of other countries?
I think my sense is that in the long term, centralization is pretty inevitable. So I think a few companies, at least
So
according to
you're
current
doing
trends.
kind of like operating systems and going down to 2 or 3 operating systems?
I think that's right. So I do think it's less like operating systems in that operating systems are much easier to sort of port to another language. Like you
Yeah.
can translate all of the pieces and you've got like this exact software, but in this language.
Yeah.
With a language model, the capabilities are sharper. So it might be the case that it works a lot better in English than in, let's say, Japanese.
Mm-hmm.
But I think the reality is that the scale that it takes to train a really good generalist model and the transfer you get from English to other languages is sufficiently strong that there's strong returns to centralization. And that will lead to a few big players generally taking over rather than a ton of little players.
So what do you think will happen to the little players?
So I do think, all the little players will have their niche. Like as I kind of said, there's a lot of applications where you don't really want to be sending your data to a foreign country, like,
Yeah.
national security or highly private, those kinds of settings. You really want this like kind of chain of trust that might not exist with an overseas entity. And so I do think there's like a market and a niche for all of these models, but I don't really imagine a future in which one example might be like Yahoo Japan versus Google, right? Like there was this balkanized infrastructure in Japan that was separate. I don't imagine that. I imagine the common thing that everyone uses to be sort of almost global.
Well, I am kind of curious. This is my follow-up on this. We seem to have shifted to agentic AI. So if you have a multi-agent where each agent is working with its own set of LLMs or whatever, does that lessen the need for gigantic big LLM?
Um, so I don't think so. In the sense that, this is a thing that I hear often. People will say things like, I only need a language model for this specific task. Can't I have a teeny tiny model? And I think what you get from the big model is not the ability to do many tasks. That is one of the things that you get. But one of the things that you get from big model is just robustness, right? In the sense that a model that is really large and has been trained on tons and tons of data, it's just seen lots of things. It's seen lots of situations. It's seen lots of text from people. And so it's a lot more robust and adaptable to unusual user inputs.
Well, and actually that kind of goes to something I've wondered about for a long time, and that's how it can read context. The things that are, the in between the lines things that we understand from reading texts that really involve context knowledge. It involves a lot of encyclopedic knowledge.
Right.
That's very important in some Asian languages.
Right.
How does
I don't
accommodate it?
Yeah, I think, there are things that I think are less textually stated that are important. I can only speak to my own life experiences, but there's lots of social things in Japan that are sort of like less clearly stated but very important. I think I do acknowledge that those are important and difficult to learn things, but also I think one of the things that we've learned by developing and like studying LLMs is that a lot of the things that aren't stated explicitly in text are still often learned through language modeling.
Yeah.
The example that NLP people used to always tell me was, language models can't really understand the sentence. The elephant couldn't fit in the door because it was too big. Because no one writes that sentence, on the internet. And it's true. Like I don't think anyone, other than NLP people have written that sentence on the internet. But it's not really hard to put all the pieces together to understand that sentence, right? And I think similar things happen with language models. Like they've seen lots of bits and pieces of all these contextual knowledge, and they know how to recombine them to do prediction at the point of time.
So let's go ahead. Your hand was up.
Yeah, just first wanted to say you're an exceptional speaker. It's amazing to listen. Maybe a bit of a silly question, but can you explain how like the CPT, the continued pre-training works? Like, and why is it cheaper mechanically? I get that it uses less tokens, but we're not understand that all. And also, what is the benefit for Quen to allow people to build off of their base model?
Yes. Okay. So the first one, continued pre-training. So this depends on a lot of the details of how language models work. So we could live in a world where it's really difficult to adapt a language model to a new domain, right? In that world, there's no benefit to continued pre-training. You just have to start from scratch and just put in, billions of tokens of text. But the world that we do live in is a little bit different. And the world that we live in is that language models, on the basis of a small amount of data, can generally adapt their distributions very well. And so CPT, or continued pre-training, works very well because if Alibaba Quen has spent, let's say, 3 trillion or 15 trillion tokens training their model, you only really need to bring, let's say, 200 billion tokens. And you'll get a model that's like roughly as good as, let's just throw out some numbers, like if you trained a model from scratch on 10 billion times. It's not quite as good as if you did it from scratch, but you're getting a model that's pretty good for that domain. And so on the whole, if you want to build a model for like a really niche target, something so niche that the base model can't do it, these kinds of CPT or fine-tuning strategies can be quite effective. And the reason I think, going to your second question, for why the Quen team allows this, I think is related to what I said to Richard. One of it is legitimacy and prestige. Like maybe Alibaba thinks that they're not going to get money from those customers anyway, and the value of having people use Quen is higher. I think there is other components of if everyone is building on Quen, then it's a lot easier for Alibaba to basically dictate how the AI ecosystem evolves. This was the stated rationale that Mark Zuckerberg had for a really long time for why Llama models were being open sourced, right? He was basically saying, if everyone builds on Llama, then we can kind of control the AI ecosystem, right? Like everyone who's open source builds on our systems. And so that allows us to have better talent. Everyone's building APIs around our models, like evaluations are targeted towards our models. So that is a rationale. Given that open source future at Meta is a little sketchy, I don't know if that's quite as compelling of an argument as it used to be, but that is another argument that one might make. The third one, which is more geopolitical, is I think depending on how tinfoil hat you are, there might be state involvement in, for example, governments sort of encouraging other countries to use their models. I don't really think there's ever been solid evidence of that, but it is a thing that's plausible.
Okay, great. What about models for physical AI? Robotics? Is this going to be a totally different world?
So I think this one is still open. I think there's still vigorous debate about how hard is robotics? What does the right kinds of things for robotics look like? So I can only tell you my personal take on this. And my personal perspective on this is that I think video models, if appropriately scaled up and executed, will be the same kind of thing as language model was for NLP. In the sense that language models allowed us to take abundant sources of data, which was internet text, and essentially get all of this hard language understanding stuff out of it. Video models, similarly, if appropriately scaled up, I have reasonable belief that it will serve as kind of world understanding systems. Like inside of those weights will be encoded a lot of the physical dynamics of the world, and then we can bolt things on top of it to basically control robots.
So to follow up, one of the people who is online today is Shane Gu, and he's really co-host of our series. He's introduced a number of the speakers to us. Shane mentions that before 2012, before really all the work on GPT started, that Chinese were really dominant in computer vision in conferences.
Yes.
Do you see them having a big advantage in this for physical AI then?
I don't know if I would call it a big advantage. I would maybe put it analogous to the situation in NLP. Like there's just this big, I wouldn't say latent, there's this big talent pool, right? Like the fact that they've engaged in this R&D for so long for basic science. And if you look at, for example, ByteDance Seed is a great company that does this. They've built and published video models. They do lots of careful basic science research. And so, if there's a future in which, for example, video models and foundation models like that are important, they're going to be very well positioned to take advantage of that.
Okay. Shane, I think if you're there, why don't you speak up and ask the question that you asked about strategic vulnerability?
Sure.
Yeah.
So it kind of it was a really great talk. Thanks for coming. Do you foresee a strategic vulnerability for the US application layer or post-training as a service unicorns that rely heavily on the open weight ecosystem, given the increasing dominance of Chinese labs in that space? And specifically, is there a risk that meeting their fiduciary duty, basically, gross targets necessitates a dependency on the foreign R&D lab to compete with domestic closed labs?
Wait, sorry, I couldn't hear the very last part after fiduciary duty. I followed everything up to that. Can you repeat that very last part? Sorry.
Yeah, basically, is there a risk that to satisfy the obligation to stakeholders, they have a strong dependency on foreign R&D to compete with the domestic closed labs?
Yes, I absolutely agree. I mean, in general, I mean, even more than you sort of started this off as like the foundation model tuning services. So things like probably thinking machines is a good example of this. But really, I think all of the open source ecosystem in the US builds on Quen models, right? Or Quen models-ish models. And so all of those companies have very significant dependence on, the Chinese open source LM ecosystem. And if it turns out that, for example, they're implanting backdoors into the model, I think that would have pretty grave impact on all of those companies, right? Like I think that is definitely the case. And given that Western open source LM training is generally on the decline, it's just not profitable or doesn't have really a good return. I do kind of think this trend is only going to get worse, right? Like I think generally speaking, the companies willing to do this are probably companies that have more to prove, not in the US. And that's going to lead to probably dependencies that are suboptimal in the way that you describe. So I think, yeah, that's an unfortunate, I would say, future. Although, Google has done a great job with Gemma models. Like those models are good. They're open source. I do think, that and like open source models from OpenAI, I think they are reasonable alternatives. And so if that keeps up, maybe it's not totally fatal if there's dependence on Chinese open source models.
Thanks. From the floor. Question. Go ahead. I see your hand.
I was wondering what is driving the difference in the economics with respect to the Chinese model versus the US models, right? There's like 10x in terms of pricing differences in respect to tokens.
Yeah, I mean, the 10x pricing differences, I think, are very strange objects, I think, because partially, I think the Chinese models are often very aggressively quantized. Like if you use the models through the API, they're not actually quite as good as the benchmark numbers. Even in the US, you'll find kind of cut rate vendors for open source models that do kind of similar things. Not all of them do this. This is also true, but I do kind of think that dynamic is generally heavier in a lot of like the really discount Chinese models. The other thing that I'll say is I think there hasn't been quite as much volume on a lot of the Chinese API. So one good example of this would be DeepSeek. So when DeepSeek initially, like after the hype happened and like they did their release, they had like pretty low pricing. And they also had a thing where it's like, if you query the API during nighttime in China, it's cheaper, right? Like they had all these things. But it turns out that if you like tried to really get a lot of tokens out of them, you couldn't because their capacity was very constrained. And so I think the dynamics of sort of token selling in the Chinese APIs is very different than the dynamics of token selling in, for example, OpenAI, where they're like, OpenAI is serving tons of volume. Like if they're serving even a tiny bit below cost, they will go bankrupt. Whereas I think the Chinese companies, they don't have as much volume and they have a lot of pricing flexibility in various ways. So I'm not that convinced that that is like the true cost of serving for these models.
Thank you. Other questions from the floor? So let's talk about hallucination. How do you see the future restriction, elimination, mitigation of hallucination?
I think they will never get eliminated. Maybe my opening, remark on that one. Because the way the language models are created, it's kind of like this big neural soup, right? Like we don't really precisely control any aspect of this model. Like we just kind of shovel in pre-training data and we stir it with GPUs, and then we shovel in post-training data and we shovel it again with GPUs. And out comes this like neural soup. And it kind of does the thing we want most of the time, but not quite. I forget who it was, but someone was telling me a really good a phrasing, which is something like, language models are grown, not engineered. And that's kind of right? Like we're growing these systems in very specific ways. And given that we're like growing these systems in the same way that, my daughter doesn't listen to me, the language model is going to do some crazy stuff every now and then, right? So I don't think that's going to change, but I do think the science of how to engineer data to control these models and the science of how we apply algorithmic controls to like better shape how things are growing, it's just improving, right? So the hallucination rates will continue to drop. We'll figure out how to put context, better. And I think eventually this will become one of these things where it's like, well, you can't always trust the language model, but 95% of the time you can. And I think that's kind of the future that will stabilize.
So this is kind of related to one of our questions online from Tara, which is whether we should really call this pre-training still, or is it really just fine-tuning from now for the big models?
Well, I mean, okay, so there's a sense in which I think that the term pre-training is no longer really valid. which is that, it used to be that when you train a language model, you would do pre-training, which was like predict the next word at scale.
Yeah.
And then you would do post-training, which is like make it do instruction following and tasks. And in order to chase higher and higher sort of levels of performance, all the companies have basically started to blur the line, right? Like they pushed post-training further and further into pre-training. And they do some pre-training-ish stuff, later on as well. So there's like a mix. There's mid-training. There's also other stuff that happens. But despite that, I think, there's a phase of the training that is like purely next word prediction, no matter, what is happening. And I would call that still pre-training. And I think there's still a pretty clear separation between the different phases. There's this compute intensive phase, and then there's this like more hands-on phase.
Yeah.
So that's not going to change, I think.
Okay. So why don't you go ahead?
I don't know. You probably heard about like Mercor and like Scale AI and all of these things about like getting domain expertise for a lot of foundational models. I'm curious on your perspective on how, as we get to like very, very like high level, hyper specific domain experts on like foundational models, how we continue to guarantee accuracy in them.
You're right. So the supervision gets harder and harder as the models get better. This is like definitely the problem, or a major problem. And I think, especially if you want models performing at the very bleeding edge of performance, you want to like purge out any errors in your like post-training data, because that, has fairly significant impact. And that's why kind of companies like Mercor have done quite well, like serving these like very high quality things. I think lots of people vary on like where the important bits are. At least my own personal bias is that, at least to me, the most important bits are still pre-training. Like basically a lot of the breadth of knowledge that models acquire is through large scale internet or other uncurated text. That's where most of the action is. And then a lot of the data that comes afterwards, it's very surgical. You're adding like specific kinds of knowledge, or you're pulling out really desired behaviors from the model. But it doesn't have the same breadth. Like you can't scale up expert data the same way that you can scale up pre-training. And so I think, the part where, as you said, like what do we do as capabilities get better and better? I think the real question is, what are we going to do about the pre-training phase? The post-training phase, at least you can keep hiring better experts, or doing like more consensus or whatever. But pre-training is a part that there's serious questions about how that's going to scale in the future.
So I'm curious how you see edge AI developing. What you were saying about the Chinese being restricted due to export controls to lower input-output bandwidth from their GPUs might indicate that they would have an advantage in moving toward more edge AI kind of architecture.
Right. Yeah, I mean, edge AI might be difficult because I wouldn't say like fundamental, but no one has yet found a way to make a really tiny, low-powered model do well. Like there's just kind of, I wouldn't say fundamental trade-offs, but there's sort of limits.
The model, but
right.
Yeah. The model would actually have to be distributed.
Exactly, right. So then the model will have to be tiny, right? So in order to do these kinds of edge AI things, someone would have to figure out a way to make a low-power version of these models. And that's been something that no one's yet been able to achieve.
Yeah.
And so I think, they do have advantages in things like, having been forced to do quantization and so on. But I think there's just sort of physical almost limits to, how far you can push this. So I think that's going to be difficult, no matter what happens.
Okay, thank you. Question. Okay.
So yeah, thank you for the lecture. It was really interesting. And like it's also interesting that like the DeepSeek found a way to engineer the system to overcome the spam. So in the long term perspective, what extent that you think like DeepSeek and other Chinese LLM companies can overcome like that issue? Like at some point, they probably don't need the GPU from NVIDIA, or they still need the NVIDIA. So how should we think about that?
Yeah, my sense is that, if the administration wants to really hurt the Chinese companies, they could really crack down on chip exports very hard, like much harder than they have, like not even allow for sales of, any cutting edge GPUs at all. But I think that's probably at best a few year advantage. And a few years is maybe significant if you assume that the progress of AI is very fast. But at least to me, it does not feel like very much at all. Like after a few years gap, if the Chinese semiconductor industry catches up, it's kind of all over for export controls. As you can kind of see with the Huawei Ascends, it's not like they're so far behind that they're not competitive, right? Like they're capable of designing and fabricating fairly good chips. And I think a lot of what's, interesting about language models is it's not, incredibly difficult technology, right? Like the chips are fairly simple. It's like matrix multiplies, right? So you need a systolic array, you need a big one, and you need some very fast memory. And it's very hard to execute, but it's not rocket science. Same thing with training a language model. You just need a lot of tokens that are very well curated to go through those matrix multiply units. And so I think in many ways, I think we overestimate the extent to which we can control and steer Chinese LM development. And I think DeepSeek is V3, for example, is a manifestation of that fact.
So, Tatsu, let me ask you a little bit about your research. How are you able to make more robust models and more reliable? What's the kind of approach you are following?
Yeah, so I think my research has been kind of interesting in how it's shifted. I spent a lot of time thinking about, how do we use math to make models more like reliable? Because I thought that was the way to make, models, ML systems more reliable. But then, when GPT-3 and these other models came out, I kind of realized that actually maybe the most important things for reliable systems is the data, right? Because when you interact with ChatGPT, you kind of realize this thing can do tons of tasks. I can like talk to it in all sorts of weird, unusual ways, and it can still understand me. And really why that's the case is because it's done this like gigantic amount of unsupervised learning. And so my recent research has been basically focused on this question of like, what is it about pre-training and foundation models and all this unsupervised stuff that people are doing that allows models to be so adaptable over different environments. And so I kind of study things like how do models scale, how does data transfer from one setting to the other? And so sort of those are the foundational questions that I'm interested in.
So that kind of brings up the whole question of where does university research fit into this future?
Mm-hmm.
And not only here, because, you've got the gigantic models that are really only industry has access to.
Yes,
And
absolutely.
so the university has to find a new.
Right.
What about the situation in Asia? How do you see the university research in AI?
Yeah, so I think my take is maybe slightly different than many other computer scientists. One of my PhD backgrounds actually is I used to do computational biology.
Okay.
And biology is a very different place because if you do biological research, you don't like work on patients. Like you don't like go and give drugs to people to like test your ideas. Like you have like yeast, you have like stem cells, you have these like model systems that you carefully study and understand. And based upon that basic biology, you basically stage out drugs to clinical trials, right?
Yeah.
And I think AI research is very much going to become like that, right? Like we know that compute and scale and data are all very important, but that's kind of like the clinical trial, right? Like when OpenAI does a $5 million run, that's the clinical trial. And the role of academia is not to run the clinical trial, it is to basically build the equivalent of yeast and to understand it fully and to be able to sort of stage out that pipeline. And so this is kind of why I said I study things like scaling, right? Like I need to understand how to scale things down so I can do the science that can then be scaled up.
Okay, thanks. From the floor. Go ahead.
Do you see any diminishing returns with scaling loss and hardware scaling, or is that still ripe for?
Yeah, I mean, the diminishing returns piece is one of the things that's hard to reason about because models are now no longer these like pure objects where you like take one axis and you scale it up. Like, today Gemini 3 got released and Gemini 3 is pretty good. Like if you look at the benchmark scores, it's like a minor or like non-trivial jump. You're like, wow, it got better. But why did it get better? Is it because they scaled it up? Is it because, I don't know, Shane got involved? Is it because, post-training, team like really like pulled out all the stops? Like we don't know, right? And so I think the various like discussions and things that we hear from the industry companies is generally like, the obvious kinds of scaling has become more difficult, but pre-training still hasn't, fully tapped out. That's kind of one of the things that Google has been doing very well in, and Gemini has done very well through that. And I think the other thing is that there's other axes of scaling that have panned out, right? Like the RL stuff has panned out quite well. Test time scaling has panned out. So I think it's pretty premature to say that compute scaling as a whole has, sort of stopped holding. One last thing I'll add to that is I think people don't quite appreciate that scaling laws are polynomials, right? So like, what do I mean by that? I mean, a polynomial is something like a square root. So a square root is much slower than linear, right? Like eventually that thing slows down quite a bit. And so we should expect some level of slowdown with respect to every additional unit of compute. And so it's not that the expectation should be same progress forever. The question is, are we still following that kind of square root or whatever other polynomial, or have we like fully tapered out into like a flat line? Because that's really the more concerning outcome.
Okay. You mentioned that fabrication is harder outside of the US. Why is that? I thought all of it happens in Asia. No?
Sorry, you mean when I was talking about semiconductors? Yeah, I mean, I think that's basically US allied countries, which is like Taiwan, right? And so if once you exclude Taiwan, then the bar chart is going to flip quite a bit, right? Like if you break that up.
So generative AI, the word generative means that it's creating really deep fake data. And because it focuses on the generation of new data, how about the other side, the ontology, the kind of interpretation that happens? We are told to be careful because something like ChatGPT is not trying to understand what you're saying in the same way that a human would.
Right.
Is there research in that area going on?
Yeah, I mean, I think there's a lot of research into understanding like cognitive differences between people and language models. I think it's hard to say what exactly, like language models are certainly different kinds of intelligences. I do think though, we overemphasize the extent to which people are rational, and people are like well thought out. I think a lot of our day-to-day lives,
how people survive, frankly.
right. I think a lot more than we realize is very autonomous, very systems one, very reactionary in the same way that a language model might be. And I do think, humans still have quite a bit of advantage in like kind of systems two kind of thinking, like really thinking carefully and methodically and checking everything. But even there, it seems like a lot of the, long context, like thinking models start to replicate some of the behaviors of humans. And so if anything, I think a lot of the language model phenomena, at least talking to the cognitive or linguist friends that I have, really are more of like, well, what is it that makes humans kind of very unique in cognition? Because slowly but surely models are eroding a lot of what we thought was very unique.
Okay, thank you. Other questions? Go ahead. You had been patient.
Wait, thank you for your talk. It was really interesting. I was kind of curious about the part where you talked about biases and cultural values that can be embedded within these LLMs. In terms of like sovereign AI and countries that aren't developing their own foundation models but are using like continuous pre-training or like post-training, like how do these forms of training affect the values that the like outputted LLMs have?
Yeah, so there's been a bunch of like fine-tuning and CPT papers that show that you can kind of steer the model's opinions and values through secondary training processes. And so I think that's generally good news. I think the difficult things on that front are you never really quite know how deep the bias goes. And this is almost like an unfalsifiable thing, right? It's like, well, we've like rooted out all the things we can measure, but maybe there's something even deeper that we can't measure that's kind of deep in there. And so I think that's part of the sort of discomfort that people have with CPT and why people might want to do base model training, which is, maybe there's like deep unmeasurable biases or even backdoors that we can't quite catch or measure. But I do think like for every measurable benchmark that we have, people have been able to steer through CPT and fine tuning.
Okay, thank you. Go ahead.
If I'm a structural engineer, and I'm building a bridge or a building, accuracy is incredibly important. The consequences are obvious. On the other hand, if I'm a tax attorney, what I really want is AI to look for as deeply as possible the loopholes that are legal, say, for my clients. Are we going to have siloization or silos in AI as a consequence of this? If I'm a politician, I might want a different answer in a different country to a specific question. How is this going to work?
So are you thinking about kind of customization or personalization almost? Like different people have different needs out of their language models. Therefore, will we have sort of specialist models for different sectors or different areas? Or
people, I would say profession.
Professional. Okay, yes, but okay. Okay, so I have some different answers to this. Maybe the first order one that I'll start with is maybe before the great success of ChatGPT and other systems, I think my perspective would have been something like, yes, we do need different models because it's very hard to get models to do exactly what you want, in different sectors. But I think more than anything else, what we've seen over the last few years with these systems is that you can control systems very well using language, right? The success of a lot of these prompting style things and like the ability to steer models in very precise ways using language, I think has been a really big change. Before we would have said you have to build models for specific tasks. Now you just ask models to do the task with very precise constraints written in. I think the places where you can't do this is where you need the models to do something like very precise, right? And by that I mean, I need the model to have like this precise word use. Like I want the frequency distribution of the responses of the model to be exactly like this. If you've ever tried to get a language model to like mimic style of writing or something like that, you'll sort of know how hard and frustrating that task is. But for something along the lines of like, I want you to like look carefully through every loophole, that's not really this fine-grained thing. That's like a very binary thing, like do this constraint, right? And those things I do think can be linguistically expressed and linguistically sort of, transmitted to the model. So those I don't think require personalization.
So do you think that we have a question online actually from Hiroseki about companies developing, their own LLMs, proprietary LLMs tailored to their organizational needs?
Right.
Do you think this trend is going to continue?
I think it's an interesting one. I think I've talked to people that sort of have strong beliefs in this direction, and I can see the argument for it. So like companies might have almost like cultural values almost within the companies, right? And if you're like a company that has very strong sort of brand image and brand attachment, you might really want to deeply embed those values into the model. And that's almost one of these like sort of precise things. Like you want the model to like really understand the nuances, like this fuzzy nuance of what it means to have this company value. Then maybe you want to do personalization. But if you're building something like, I want to sort of have a model, know some facts. In most cases, I think those can be done by putting the facts into context, for example, right? Like I think those are doable. So I think the use cases for in the settings where personalization is appropriate, I think are quite nuanced, maybe more so than it might seem at first glance.
Okay, so where do you see the interest in sovereign AI going? Is it going to fragment the AI world, or will there be ways in which these models can be deployed?
I don't think they'll be fragmented, mainly because I think models will kind of centralize a lot more. So I think everyday users of models will kind of sort of cluster into sort of some of the top model companies. So,
So you can acquire a company, do you acquire a model and somehow integrate it, fold it into a bigger one?
I don't think you can quite merge models that way.
Yeah.
I think that would be quite difficult. So I think OpenAI, for example, acquiring Anthropic wouldn't give them advantage in the models. The people would be helpful.
Yeah.
But what I sort of mean by that is I don't necessarily think like sovereign AI efforts are going to fragment consumer users. Because I think consumer users are going to still use the same few language models no matter what. What I think the sovereign AI effort will do is I think it will kind of distribute AI training effort and talent across different countries. And I think for very sensitive applications, I do think there will be like geographic localization. That's kind of the future I mostly see right now, at least.
Okay. How would you deal with a country that's severely multilingual like India?
Yeah.
You've got not only 22 official languages,
That's
but
right.
hundreds of different dialects that have to
That's
be
right.
coordinated.
Yeah, I mean, I think that's one of so Southeast Asian countries have a similar thing. Like, for example, I think the sea lion, maybe was it model, like their target is to support like a couple dozen languages or something,
Yeah,
Southeast
yeah.
Asian dialects. And so I think that is a complex effort. And I think not all the dialects can be reasonably well supported. I think one of the biggest challenges, I didn't talk about this at all because I think I focused on the big players, is
It's also East Asia, which
Right.
is a little different.
right. The low resource and very low resource regimes are quite different because there you just don't have enough data, even if you have the compute, to be training models for those domains. And they require more exotic techniques to get them to work. And so there's basic research that's still needed to sort of cover all the tail of these dialects.
Okay. Do you see a practical upper limit to the size of a model? I mean, we have a question online about what do you think about models like Grok 5?
Well, I
that
think
could have what? 5 trillion.
5 trillion.
5 trillion.
5 trillion, yes. I think there's no physical upper limit to the number of parameters. I think, in practice, what has limited the number of parameters is the economics. Like
Yeah.
there's just, the returns.
That's also energy as well as just plain
Absolutely.
simple cost.
Because the companies have to pay for inference, right? So there's a very strong incentive to like shrink the models down as much as possible while keeping the capability. So I think if anything, the pressure is like the other direction. No one wants to serve big models except as a kind of almost prestige project. But that said, I do think, compute is getting cheaper, right? Compute is getting cheaper and cheaper. And I think there's demand for higher, more reliable intelligences. And so I do think, generally speaking, we might see a slow trend upwards in the size of the models that are being served. Because, I don't know if this is like always the case, but generally speaking, I don't really care if, OpenAI shaves another zero off their cheapest model. What I really want is, really good intelligence, like you all, level of intelligence, but at a reasonable price. And that might be a big model served on very, very powerful hardware.
Okay. Other questions from the floor? Back in the back. You're it, yeah.
Sorry, for
Well,
another.
I saw your hand too, but go ahead, you first and then you.
I was wondering, what's your opinion on like quantum computing, that's effect on like AI? I know it's gonna be a
Go
couple.
for something completely different.
I will say I think about it, because I think about a lot of, things that are like, what's next after all of this stuff? I mean, there's the near future, which I think is like the video stuff. And then, after that, what comes? Like, is it quantum? Is it brain computer interfaces? There's all sorts of like fanciful sci-fi things I think about. I'm not enough of an expert to really say whether that's going to change the landscape of AI. I just think it's too far out. Like anything that's further out than 5 years is impossible to predict in this field. So I have to kind of say the cop out of I don't know.
Go ahead.
My question is more about architecture. Most of these recent Chinese models, DeepSeek R1, Kimi K2 thinking, are mixture of experts kind of model, and even Mistral was doing that. So is there a particular architecture that has been evolving or doing particularly well? And is that to support multimodal requirements? Like, what's your thoughts on that?
Yeah, I mean, MOEs have taken over because they're just hardware efficient. They just make sense, right? You get more parameters without paying for the hardware cost of more parameters. And so you can kind of pack more knowledge into those experts that aren't active. And, as you correctly note, I think DeepSeek and shoot, who was the other one? Quen, maybe? Quen? Yeah, I think it's DeepSeek and Quen have pioneered basically the modern open source mixture of experts architecture. And I think that's primarily for hardware efficiency reasons, not for like supporting multimodality per se, because multimodality you can support with a dense architecture just as well. It's really just like MOEs are just much more hardware efficient. And I think the other things that people are doing, like DeepSeek has multi-head latent attention. Other people have like hybrid architectures involving like state space models and things like that. They're all driven by hardware. Like how can you drop inference costs as much as possible while preserving capabilities?
So do you see an AI bubble?
Do I see an AI bubble? I mean, only in the sense that the valuations for some of the companies, I won't say which ones, seem like ridiculously high. Like maybe I'm just, a person of little imagination, but I just like can't possibly see the way in which like the profits and revenues kind of match up. But that said, there is very much transformative possibilities here, right?
Yeah.
It's not really like, I don't know, like
Yeah,
a real estate or crypto bubble,
Yeah.
but the technology is very real, and it's still a technology that is in development, right? Like there's a lot of R&D sort of angles of attack that have not yet been exhausted. So I do think as a technology and as value provided to society, I don't think it's a bubble. In terms of the, financial aspect of things, maybe it is a bubble. It's hard to say with that one.
Way back in the back, go ahead.
My question is about actually specifically the Chinese models. In China, there's obviously extensive censorship, and one thing that censorship requires is rapid changes, even changes in the real world.
Yes.
And I'm wondering if there's anything about the technical infrastructure or social infrastructure, to your knowledge, of the Chinese models that would prevent or enable that kind of like rapid response to ongoing world conditions.
It's a great question. Yeah. I mean, I think, I'll give the technical answer first and then maybe kind of the infrastructural one after. So like at a technical level, there is no great reliable technology to adapt a language model reliably. So like if tomorrow you tell me like, I want you to take DeepSeek, but make it not talk about, what's a non-controversial thing? Elephants. I was about to say something more controversial. Elephants, right? No, don't talk about elephants. Then I can't really do that without doing a lot of compute, right? Like it's very difficult to just like remove elephants out of the model without totally breaking the model or, retraining a large part of the model. And so because of that, basically a lot of the hard interventions that people do, so this is the infrastructural part, are layers on top of the model. So if you ever like interact with ChatGPT and you like ask one of the names of people that are like in active lawsuit with ChatGPT, like you can clearly notice that some other like router will trigger and then it will be like, I can't answer your question ever. And then like, it will just like, terminate the conversation. And it's like pretty clear that like they have another layer on top that's like detecting these queries and like routing them and doing things. I think all of the API vendors basically do this. I am surprised in some ways that, Chinese authorities haven't tried to figure out how to like deal with open source models and things like this for censorship. But I think that's not a thing that, as far as I know, has happened where like, DeepSeek like continually updates their open source weight releases to comply with, rapidly changing censorship requirements.
Well, where you are you seeing a movement toward harmonization of the concept of responsible AI or kind of, multinational efforts toward AI ethics?
So I think there's definitely things that people agree on. Like if you look at some of the early AI safety laws that came out of China, they were like, other than, the sort of things where you could say like, oh, this is like clearly state censorship in action. There were like lots of reasonable things. There was lots of reasonable things about like, oh, you need to do provenance tracking. Like you need to, know if like you need to report to the state if like someone does something really bad with your model. Like those are also things that people talked about for the EU AI Act, right? So I think there's like a fundamental that's shared, but I think there are principles that people don't necessarily agree on across countries without, for example, how much state control should be applied to these model vendors.
Well, and that's also a cultural issue.
That's right.
Yeah. So I think that we may end a few minutes. Go ahead. Ask your question.
I have a very short question because nobody asked, but it's like hype since June, right? What about memory? So it's a big concern for the large language model, hardware, software. So what is your take on it? We'll see.
Yeah, I think memory sort of related to this like rapid adaptation thing. I think those are unsolved problems. Like I think we have current systems that can do memory-like things. Basically, like, you can have like a little retrieval system and you can put things in it. That's what all the companies that have like a memory feature do. But they're very clunky. And the way in which they trigger, you can just like notice when like a memory thing's been shoved into your context. I think the kind of memory that we have, where we have like the deep integration of the experiences of our lives into, how we behave, that is a thing where we have to figure out how to integrate these like sort of more hard discrete memories back into the weights. It's an active area of research. It's unclear to me whether there's like really great successes that are waiting for us. I think, I included, many others are working on this problem, but there's a lot of really hard technical challenges in place. At least to me, a lot of the potential technical solutions look a lot like, maybe when the model is kind of like sleeping, we reconsolidate some of these hard memories back into the weights, and we figure out how to do that in ways that are generalizable and don't really mess up the model. And if we can do that, then I think we will have the kinds of memory that you're talking about. And I think that would be transformative.
So I feel like it's getting to be about time to go outside and have some refreshments. I've got one more question for you. And before that, please remember everybody, especially those of you on Zoom from different countries, next week is American Thanksgiving. And so there are no classes at Stanford. We do not have a seminar next week, but 2 weeks from now, we have Dr. Kai-Fu Lee. So Tatsu, for students who are not computer science majors, you have recommendations for them about what they should make sure to study while they're here? How should they prepare for this world of LLMs?
That's okay. That's an interesting one. Especially the constraint about the students that are not computer science majors. Okay, give me a minute to think about this one. Yeah, I mean, I think I do think maybe even if you're not a computer science major, I think it's useful to understand kind of the historical development of AI. So I think a lot of what we're seeing is, tied to big paradigm shifts in the field, and understanding those, I think, is pretty critical to understanding the state that we're in and where the field is going. Like we had like a good old fashioned AI phase, and then we had like a phase where sort of like statistics and math was very dominant, and then we have a deep learning phase, and then we kind of have this modern sort of like unsupervised learning pre-training phase. And I think understanding like almost history of science, like I love, studying history of science, of like what was happening and like why are we in the state that we are now, helps us understand like where the field is going. So maybe that would be the one thing that I would say.
I think that's a great answer, and it's a great note for us to end the session today. Tuss, thanks for a great session.